Okay, and now we're going to talk about how to create beautiful graphs from objects moving, velocity time. Mostly we're going to talk about acceleration. That's our big topic today, is we're going to talk about how do I draw my graphs if the object is accelerating. And so I've drawn a picture here, and so we have a object, a ball, bowling ball, I don't know. It's moving to the left with a velocity of 5. So I guess if I want to be super clear about this, I probably, we'll talk about it later. Moving to the left, 5, it starts in a position of 50, then it goes 25, then it goes down this ramp here, and it's going to get down here. All right. So first thing is I can create a position time graph, velocity time graph, and eventually we're going to actually create an acceleration time graph. That's down there, so we'll get to that in a moment. But I personally always like to draw the velocity time graph first. Okay, so I'm going to start with that one. So I'm going to mark things I know. So first of all, I know my initial velocity is 5, but I am moving in the negative direction. So I am actually starting here. Oh, this is horrible because my drawings are all going to be off and I am going to suck. So let's not do that. All right, take two. Take one didn't go so well, so that's the take two. So now we're going to talk about how do you create an acceleration time graph from an object that's moving. And by acceleration time graph, I mean we're also going to create position time graphs, velocity time graphs, the whole smash. So it's going to be just like we did last unit, except now our object will be experiencing some acceleration. All of the previous rules still hold true. So when I'm doing this, I always first like to create the velocity time graph. And just for fun, let's do some color. Color. I choose blue, Pikachu. All right, let's do that. So velocity time graph. First, I like to say, well, what do I know as facts? So my initial velocity, it says 5, but that's kind of a lie because it starts at -5 because it's moving to the left. And we know that anything that goes to the left is negative and anything that goes to the right is positive. So it actually has a negative direction. So I start with the -5 for my initial velocity. Now, as we just go along, this is supposed to be flat. I mean, it's mostly flat. It's basically flat. Leave me alone. So it's flat surface, so we're not going to speed up, so we're going to travel a nice constant velocity. So for this first portion of time, it's just going to be a nice smooth velocity of -5. But at this point, we're going to go down the hill. And as we go down hills, we tend to speed up. All right. Now, if we're speeding up, there's some things we should understand. So if we are speeding up, then what's going to happen is our velocity and our acceleration will have the same direction. All right, so they both agree. So we are heading, and in this case specifically, so let's go to a different color here. Let's go with red. So we right now have a negative velocity. Why are you writing down there? That is horrible. Okay, so we have a negative velocity, and since we're speeding up, these two have to agree. So we should end up with a negative acceleration when all is said and done. So we'll see if that's true. Now, we are going along our path. We are speeding up, so that means our value, this 5 here, is going to get bigger. So we have to go from -5 to -6 to -10, etc., etc. So we have to end up down here. So time's going to pass. We're going to end up down here. So we have to have a velocity that's way down here because we're speeding up. Because the number value itself tells us how fast we're going. So we're going to have something like that. A nice little line there. All right. So remember, for velocity, let's say, for example, we have our -5 meters per second. All right. So for that, just to recap what velocity is telling us, the value itself, so this part right here, this is telling us our speed. That's how fast. All right, so if we're getting faster, then that means the actual numeric value itself is going to increase. If we're getting slower, that numeric value is going to decrease. And by that, I mean approaching 0. So speeding up, you move away from 0. Slowing down, this number here moves towards 0. Then this right here, this part that tells us our direction. So is it negative? We're going the negative direction. Positive, we're going the positive direction. Okay. So I always like to draw the velocity time graph first. I think it's fundamentally the easiest. And then from there, I like to go straight into the acceleration time graph because we have defined acceleration in our class as color, let's go purple, acceleration is the slope of the velocity time graph. So therefore, acceleration equals delta v over delta t. All right, so if we look, the slope of this line right here is 0, no slope. So that means for the first moments of time, we have an acceleration of 0. All right, no acceleration because we have no slope. But then if we look at this, this has a negative slope. So that means we must then have a negative acceleration. So constant negative slope on a velocity time graph would mean a constant negative acceleration. If this is a positive value, then we'd have a constant positive acceleration. Because again, by definition, the acceleration is the slope of your velocity time graph. All right? And if we look at our hypothesis, we said the object is speeding up, so it should have a negative velocity and then a matching negative acceleration. Look, we end up with a negative acceleration. So it looks like our hypothesis is right. It did speed up when it rolled down a hill. Reality did happen. Yay! All right, now for the hardest one. And this is the position time graph. At least I think it's the hardest. All right, let's see. Fun color, fun color, fun color, fun color. I'm red in all my board games, so I choose red. All right, so here I know my initial position is 50. So I'm going to start here at 50, and I end up going to 0. So I'm going to call this 50, and this is 0. And somewhere here we got about 25 happening. All right, so I know I start here, and I know I'm going to end up getting down here at 0, because time's going to pass, so I'm going to end up somewhere down there. Where exactly, we'll see where my art skills take me. But I know that for the first part, I had a constant negative velocity. So if I have a constant negative velocity, remember, velocity, so I'll go back down here to our velocity. Velocity is also the slope of the position time graph. So if I have a constant negative velocity, that means that I must have a constant negative slope. So this entire time, I'm going to have a nice constant negative slope. All right. Now, during this last part, though, I was speeding up. So if you look, as my velocity, as time passed, my velocity went from a -5 to a -6 to a -7 to a -10, and it just kept speeding up. So my velocity kept getting more negative, so that means my slope has to become more negative. So I had a straight line here. The only way to get more negative is to have a downwards curve. So down, 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 down. I got a bit of a curve to this. I know I didn't end where I said I would. Like I said, it depends on art, and you're speeding up, so you're going to cover the same amount of ground in less time, things like that. And so this is a line, and this is a curve. All right. So again, this had a constant negative slope, so I had a constant negative velocity. This slope kept getting more and more negative, which is because my velocity kept getting more and more negative. So all of your graphs always need to agree with each other. And that's basically how you draw a position, velocity, and acceleration time graphs based on an accelerating object. I hope you had fun. Come tune in next week when we do something else that's probably related to physics.